Gotcha.
Okay. All right. So welcome to lecture 2 for packaging 450. I hope you're having a great day. And if someone else, we'll see if anyone else joins, they can join throughout. People don't have to join it too. If they can't get on till, 2:30 or 3, that's fine too. And then they can always look at the lectures. But Brandon, again, if you have any questions, any, comments or whatever, as we go through this, feel free to, jump in. So I think the luxury of being the only person on right now is that you don't have to worry about raising your hand. So that's great.
Very
Okay,
true.
so let's see, I'm going to share my screen. And I'm going to go through these notes, and I have a few slides and I put some supplemental information in. So I put a couple things into D2L, and just keep in mind that those supplemental pieces are not necessarily directly related to the homework or the grading, but they are things that if you are working in automotive packaging at some point, these are great reference tools to keep with you. Okay, so we ended here. So we were, when I finished yesterday, we were talking about the comparison between returnables and expendables, and we talked about some of the pros and cons of both yesterday. That's where we finished up, and I wanted to very quickly pull up just a few slides that I have here. Oh, that's not what I'm looking for, sorry. Okay. Okay, so we're gonna go here in just a couple slides. And I just wanted to talk about some of the considerations for packaging when you're looking at expendables versus returnables. So you're looking at the launches, what kind of launches are these, what the timing is, what the volume is, who your supplier is, where they're located, those sorts of things, as you look at launching and what that full timeline is going to be. The next thing that you want to look at when you're looking at returnable versus expendable, are there any opportunities to improve cost or save money by using a returnable pack or an expendable pack? And then there may also be opportunities to redesign your pack and get more parts into the pack. So I'm gonna pull my little handy examples out again. So if you have this bin here, I have some random parts in here, right? If you put these in a small tote or small handheld bin, you may only be able to get 2 or 3 of these in here, but if you go to a bigger bin, you can get more in. Or maybe you can change the arrangement of how these are placed in your packaging and get more, whether it's returnable or expendable. So that's an opportunity to get more parts per cubic foot or cubic inch in your pack. Next, you're looking at increasing your return ratio. So if you're doing a returnable pack and you're sending your parts in, say in this tote, but you're sending it back empty, this tote is going back empty, this one does not collapse. But if you have one that collapses, and you'll see some examples of that later in chapter 1, if this collapses, you can send more back. So like let's say if this collapses down to 1/5 of the size, so for every one you send, you can actually collapse it and send 5 back. So where you might need 5 trucks to send parts in, you would only need 1 truck to send back. So you can save on your what's called the return ratio that way, and you're paying for fewer trucks, less gas, and fewer drivers, etc. You also want to look at, where do you use expendable versus returnable? So there might be key locations or even key parts that you will see traditionally they stay in expendable. And also, let's say if something's shipping from overseas, it may not make sense to use returnable because it could get lost. Or if you have a supplier that tends to lose things for whatever reason, you might want to consider expendable. And then this goes ties into the container tracking. This is really understanding what your suppliers are doing. If you're using returnables and you have some sort of tracking system, it's really important to understand where your containers end up. Because if you're sending, the example I gave yesterday, we've got the pink and the blue. And if you're sending everything to supplier blue, then supplier pink is out. And you would only know that if you have a good methods of tracking or visual management or really, tight processes, and a lot of discipline on what you're shipping and how you're shipping things back empty, as far as empty containers. And then you want to also understand, who your key stakeholders are. So are you shipping your parts to an OEM, and they have some strict guidelines on who buys the packaging, what kind of packaging you buy, what parts of the country this packaging is shipping to. Also in your plants, who are your biggest users of packaging and how does the packaging impact them, whether they're an operator or they're ordering materials. What kind of equipment does this go on? Is there automation involved that would also have an impact on the type of packaging that you are using? Next, you have, I wanted to give you an example of what a supply chain looks like for a typical expendable packaging shipment. So you start off at the supplier, they pack it up, they put it in on a pallet or, in the box on a pallet, and then they put the pallet on the truck and then they ship it. And they might ship it to a DC, a distribution center, or they may ship it directly to the manufacturer where you would, unpack it or send it to a supermarket. The supermarket in this scenario, this is where it gets put into on a rack and stored before it is consumed. So depending on the facility, there might be what's called a supermarket, and that's where people go pick the product before it's taken over to the manufacturing line. Then you may have an area where you're unpacking the parts, especially if if you're looking at an expendable packaging, are going to have to unpack it at some point, whether you're unpacking it right on the line or you're unpacking it into another container. It all depends on how things are set up. And many times, because I've seen where you have expendable packaging, the parts come in and they get handled extra times to accommodate, getting to the line. Sometimes they'll set up another step for inspection, because if the part is prone to like scratching or damage, or say it's an electronic part and it could get dropped, or even, electrostatic discharge could cause the, electronic component to malfunction. Those are some of the things that would go into inspection, where you're inspecting to check to see does it function, or you're inspecting for cosmetic damage, or you're inspecting for rust or anything like that. So sometimes you might actually end up adding an extra station just for inspecting the parts. And then those parts could go to assembly. So it might go on this rack and get inspected as it goes on the rack, or it may go on a separate rack, but at some point then it gets moved to assembly. The plan in automotive is, no matter what the packaging is, you want to try to get it as close to the operator on the line as possible. So, the more times you can do that, the better. Then once it's done with assembly, you might return it. This shows a returnable, but sometimes every once in a while there are expendable packages, like really heavy corrugated boxes or wooden crates that might get sent back. They may actually get sent back to the supplier. But expendable generally is going to refer to corrugated boxes, bags, dunnage, things that normally would get thrown away. And then you have another option where it might go, once it's in assembly, that packaging could go to a compactor and get recycled, or it could go to a landfill. So that's kind of the life cycle. When I put this slide together, another thing that I put here, we'll talk about this later too, but I put these hands here and these people because this shows you like where the people are concentrated in this process. And the hands show the opportunities for the part to get touched, dropped, or damaged, or mishandled somehow. And as you're looking at the type of packaging, this would be a consideration that you want to take in. Where do you have more labor, and where do you have the opportunity for touch points to damage or turn the packaging or the product into a less than perfect part. And that could lead to some issues with manufacturing. It could lead to, shutting the line down or having to, add extra inspection after the fact, things that you want to avoid. Okay, next, we'll talk about the candidates. We'll get into this some more as we delve deeper, but when you're looking at what are good candidates for expendable packaging or what is traditionally put in like a corrugated box or bags, you see things like nuts, bolts, fasteners, anything that's shipping across the border, especially a border where they have a lot of scrutiny with customs. They may not have a really good relationship with customs, and customs doesn't always understand what they're shipping. So it may be more expedient to put it in an expendable pack, because sometimes customs will actually look at the parts, but they'll also consider the returnable package something that has to have documentation. And if it doesn't have the documentation, they might hold up that order. Overseas shipments, because it can be really difficult and challenging to get some of the packaging back if you have a returnable loop. Plus, the cost goes up the longer the distance, which goes right into if you're exceeding more than 500 miles, sometimes away from where you're shipping it to, where your customer is. It may not make sense from a transportation returning these containers back, the cost of trucks. It may not make sense to use a returnable pack because the cost may outweigh, for shipping the empties back, may outweigh the cost that you would have spent on an expendable. But again, we will get into how to do business cases so you can compare the two. Another one is if you have a weight restriction for your packaging for people to carry. And I mentioned this before, that OSHA, I think the limit's 35 pounds for one person to carry a box or a package, but automotives is lower, tends to be right around 30 pounds. So if you have a part that's heavy or dense or difficult to handle, you might want to put it in a smaller box. It may make more sense to do that. You want to make sure that regardless that your design that you do can withstand loading from the top, because if you're shipping in expendables, a lot of times you're shipping returnables, that means you have a pretty large quantity and you're going to probably fill up a truckload, or, if it's not with just this pack, you're going to have multiple returnables going in that truck from a supplier. But if you also maybe have a smaller volume and you can't justify using returnables and you end up using an expendable, sometimes it gets shipped on a less than truckload or freight type of shipment. So then you don't know what is going to be stacked on top of it. So if you have, a few individual boxes and they're going freight on a pallet, you don't know what the truck driver is going to load on top of it, because if there's empty space, the truck driver is going to fill that empty space because they don't want to ship air. They want to maximize the truck load. So you don't know what could get stacked on it. So you have to also make sure that whatever box you design is robust enough to handle anything that could be put on it. You also want to assume that if it's an expendable pack, it won't always be, but this is something you want to assume, that when you design your pack, it will be on the bottom of the trailer and everything else will be stacked on top of it. So that's an assumption that you want to make when you're designing expendable packaging for automotive. Here's an example of returnable packaging loop. You may have the supermarkets too, but there may not be as many extra steps. So, here I'm showing that, you go from supplier, put it in the pack, you ship it. but it's in a returnable pack. So it goes here. It may go to a distribution center or a supermarket, but it is this usually the returnable pack is designed to go line side, and it fits in a certain designated space. So it's not necessarily going to be taken out of that container to be put into the container that will fit on the line. It's already been designed to go in that. So it might pass through the cross docks here, but it's not going to be taken out unless there's some assembly step that is going to be done regardless. And then it would go straight to the assembly plant, and then that bin would get returned back to the supplier. You can see from the touch points, there might be an opportunity for damage during shipment if there's some sort of, shock event or something where the product may get bounced around or impacted during shipment. And then there could be an opportunity during assembly. Again, the goal is when you design a returnable pack, anything's going line side, that you want to be able to put it right at the line and not have to handle it a lot. But there may be some cases where, like an assembly, for example, where let's say that you are taking the DVD player for the back seat and you're attaching maybe a clip to it. So the DVD supplier doesn't make that clip, but that clip needs to go onto the seat. So rather than having them do those two operations on the line, they do a cost study and find that it's actually easier to put the clip onto the DVD player before it goes to the vehicle. So there's just one step for the operator. They could just put that whole assembly on. So there might be a touch point there where they take it out of the container, put it in a different container. And then, you may have some trash, but not as much, but you can see the difference in the manpower. You've got cross-docking, you've got things with assembly, maybe, but those are the opportunities for touching or for manpower. The considerations, again, this is when you're looking at returnables, some of these are actually the opposite. So whereas with expendables, you're looking shipping more than 500 miles. If you're shipping less than 500 miles, you actually probably have a good candidate for returnable. Something you should definitely look at. The quantities for packaging might be small. The parts may need protection. So the stiffness of the returnable tote, for example, is going to be much sturdier than a corrugated box in many cases. And you also have the ability to put dunnage inside of your tote. So I have an example here where you can see where I have foam dunnage just inside of this tote, and it would actually protect the part. So you can do things with the returnable to add some part protection. And this could be something that could go with every single load. It could be attached and stay in the pack, or this could be discarded. And whenever this empty gets returned without the foam in it, they would put in a new insert for dunnage. So, there are options for that. You might have a weight limit of the 30 pounds, like I mentioned before. If you have a small handheld tote, it's easier to carry that than it would be to carry a corrugated box. So that would be another time when you might consider using a returnable pack. You also have the opportunity, as I mentioned before, to use returnable standard packaging. So then you always know, how many totes go on a pallet. And then if you know how many parts are in your tote or how many parts are in your bin, it's very easy to calculate, because you know that, whenever I use this tote, I'm always going to have 24 of these on a pallet. And I know I have 10 parts. So you automatically know that pallet's going to have 240 parts in it. So it's, it's much easier to calculate those things when you have those standards set, and returnables allow for you to have established sizes and go with some standards for sizing and weights, and what the performance is. And then you can always add more and replace them if you need to. You can use returnable with dunnage that collapses, or you have containers that knock down, like I mentioned, with something like this, you could either keep it in there. This might be something, if this is a tote that collapses, that you can keep the dunnage inside of it. There are also designs for dunnage that are made out of cloth. And I think you'll see the cloth or even sometimes corrugated, but this book has a lot of different cloths in here, and I can go over that later, that you can look at that will knock down with the container when you actually fold the container down, and it will stay with it. It will also collapse and stay with it, so that when it returns back to the supplier for them to refill it, they'll just open the tote up, and that protective dunnage on the inside, padding or separator or whatever it is that's used to protect your part, will also open up with it, and you can just start filling parts again. You might want to use returnables too if you're avoiding non-collapsible shipping racks. So you can see some examples of racks, but you want to try to have racks that collapse when possible, because they're heavy and you want to try to maximize your freight costs. And then also with returnable, the cost of using those returnables, even though you have return freight, when you do that costing, you might actually have a really much better impact on the freight that you're calculating. Brandon, do you have any questions?
No more of that.
Okay. All right. So I will ask that from time to time. Okay. Trying to stop my share here. Okay. All right, let's go back. All right, so back to this, the auto industry, like I said, this was back in the 80s. You'll see this video later. Like I said, it's not tied into the homework, but it's really interesting to see how this came about. So they wanted to use as many returnable containers as possible. It can reduce the waste, like I've showed in that flow chart, that's value stream map, that you are not sending as much to the landfill, you're sending it back. You don't have to worry about recycling, corrugated, putting it in a bin as much. It's cleaner, and the level of protection can be superior because you have established standards, and there are established types of dunnage and cushions that can protect parts. And it just has a lot of advantages as far as, like, you can manage your inventory better, because if you have this in a container that's returnable and you always know you have 24 parts in it, you always have 24 parts. I've seen plants where the packaging, it's coming in and corrugated for various reasons. Same part, one box has 17, the next box comes with 47, the next box has 36, and they are just using whatever box is available. That can be a nightmare for the people that are pulling the parts, because now they have to calculate, okay, wait, we just used 37, now we're using 17. And sometimes I've seen people writing on the side of the box how many they pulled out. So it can be a nightmare from that standpoint. And it's hard to track inventory. They have more labor to bring the parts to the line. They might run out because they can't keep track of what they have. And it also, if you have a returnable that's established and it fits on your racks on the line, you can put it right by the operator, and it saves time because the operator doesn't have to take as many steps. And as I mentioned yesterday, steps are really important. The fewer steps you have, the more production you can have. Suppliers of parts, they should plan for small lot packaging, which would be totes, whenever they can, because the totes, there are established racks that fit on the line. Also, this helps when you're looking at having a JIT or just-in-time manufacturing process, because you don't have to, if you switch over from the yellow doors or from the black doors to the yellow doors, for example, you won't have as much on the line to have to take away or move. So maybe you plan for 2 hours of production, but the supplier calls and says, hey, in an hour, I want to switch over from black to yellow, then now they only have to move, 1 hour's worth of material. But if you have smaller totes, it's easier to do that. Versus if you have bigger totes or bigger bins or bigger boxes, you might have 3 or 4 hours minimum at the line. And then now you're moving all that back. You have excess labor you took extra labor to move parts you didn't need to move. Now you'd have labor to take those parts back to some place that you didn't use. So all those things add up. They really add up with the volume, the sheer volume of the number of cars that are built. I mentioned that about how much material. It says number of pieces in a standard pack should be no more than a few hours of usage. And that's why it makes it more efficient. They can handle switching in orders much more quickly. If they find out maybe even there's some defect in the parts, they can catch those defects faster, and they don't have like big bins to go through. They can narrow it down to certain lots a lot easier. Parts should be oriented inside the containers to maximize the part density, which means you want to try to get as many parts in a pack as you can. But you also want to make sure that because these packages are going on the line and the operator is going to be pulling them right at the line and they want to save as much time, if you can orient them all in the same position, it makes it much faster for the operator, because the operator is just pulling and it becomes habitual and they're not thinking about it. It's just second nature. But if they pull it out and somewhere this way, they have to turn it and lift it. And then the other one, they have to turn it the other way and put it down. That takes away from their manufacturing time, and it reduces the number of vehicles that are made in the long run. Things like barrels, drums, bags, and cans are not acceptable. They generally don't work because, especially with some of the round items, they may not fit as well on a pallet. Bags, you'll only see really used like inside of a pack. So let's say you have, something like this, and some of the parts are sensitive. They might bag these individual parts inside, bag them and then put them inside of a tote for special protection. So that's really going to be about the only time you're going to see bags. You're not going to see loose bags of material. Very rarely will you see that. You want to keep your containers to that 48 by 45 footprint. That is the standard automotive pallet footprint in the United States. Grocery, you see the GMA pallet, which is 40 by 48. But when you look at automotive, it's going to be a 48 by 45. So 5 inches difference is the pallet. So all of the returnable packaging that you see, it's based off fitting on a 48 by 45 pallet. So you'll see totes that are, they have dimensions like 12, 24, 48, or you'll see 12, 15 by, that kind. You'll see those. They're all either divisible by 48 or 45 in general. And it helps to get a little bit more, you get more parts on a trailer that way as well with those pallets versus a 40 by 48. Another thing that when you have returnable packaging, you can put identifiers on it. So you can put labels that actually can be pulled off. So you can have an adhesive that it pulls off very easily and you can reuse it. Versus if you put an adhesive label on a corrugated container, now you might rip the box and now the box is unusable for a second turn. You've got like the UFC Uniform Freight Classification, or NMFC, which is National Motor Freight Classifications. If you're using returnables, they've already met the standards for those trucking requirements that are listed in those two classifications. Okay, so expendable packaging used in the auto industry. So is not, you don't really see that much of it. Like I said, you might see it with things like fasteners, containers, but I'm sorry, not containers, fasteners in containers. But most of the time you're going to see it in what's called dunnage. Dunnage is going to be basically a void fill or a cushion that goes into a container. So, this is an example of dunnage, like I mentioned before. But also, these are some examples of dunnage as well. So you might have this, say this might, for example, might be used for door handles, right? So you have a lot of cells, but the door handles are prone to scratching, so they don't want them to get scratched. So they will put them in fold out like this, a corrugated or paperboard piece that opens up and fits inside the pack. This is another example. This is something that would go into a bin that's collapsible. So it's a soft material, which is what I mentioned before. This is a book that I had from a supplier, and these are all soft materials that can be used for dunnage. So, some are actually like a plastic. I don't know if you can really see it, but some are plastic, and then some are actually cloth. Like this is more of a cloth or felt. And it really depends on what type of material that you need. This one is a soft cloth that is more like a foam. So this might be something that it's prone to scratching, but then you might also want to give a little cushion to it. So, there are a lot of different choices that this type of dunnage can be made of, but it also can be made to collapse. So when you fold the bin, it will also fold with it, or you can fold it separately and store it inside of the bin for shipping. Okay, another reason why you might use expendable packaging is what's called backup expendable packaging. So because one of the number one edicts of manufacturing and automotive is don't ever let the plant shut down. Let's say you have, again, supplier blue, supplier pink. Supplier blue gets all the pink bins. Now, when it's time for supplier pink to ship, they don't have enough bins. So if they run out of bins, they really have a responsibility to reach out and say, I didn't get my bins back. Because if you're doing returnable packaging, there is a regular cadence, and they should know when their shipments are coming. And if they don't get a shipment when they expect it, they should be reaching out to the supplier or their customer, as a supplier, to get these containers back. But let's just say that for some reason, supplier blue gets all of the pink bins. As a backup for emergencies, the supplier has to keep a certain amount of expendable packaging on site. So what that means is if they're shipping a bin like this, that's a 48 by 45 by 34, which is a standard automotive size, or maybe they're doing a 12 by 15 by 5-inch tote, which is another standard size. The box that they ship it in, the expendable pack, has to be the same size, and it also needs to hold the same amount of parts. And the purpose for that is so, as I mentioned before, if you get different quantities, different times, it's really hard to plan ahead. It's really hard to do inventory. You get someone on the line that's used to picking, 20 parts out, and they pick 20, and then the next box only has 12. Now, wait a minute, what's going on? Now they have to stop what they're doing and get another box. Or maybe the person, when they have 20, they know, based on how many they run an hour, they need to bring 3 boxes to the line, and they come back an hour later and bring 3 more boxes. But if this box normally has 20, but it ends up with 12, they are going to run out before the next 3 boxes are brought. So it has to be the same size, it has to be the same quantity, and has to protect the part as well as the returnable pack that it is replacing. So again, the reasons for this would be as a backup in case there is an issue with not getting containers back. That's going to be the most common reason. But when it was originally planned, it was planned in case there's something like, let's say, a snowstorm or a hurricane or something where the trucks can't get through, pandemic. And you want to make sure that the parts still have a secondary pack that they can be shipped in. Another reason why you may see expendable packaging used is what's called a bank build. So that would be, let's say, a new supplier is coming in and they want to stockpile the part. So maybe there's going to be a change and the old supplier can't make the part, or maybe they're not happy with what the old supplier is doing. But for whatever reason, there's going to be either a new part or new supplier. And they want to make sure they have a few extra just in case when they come in, just to make sure they're working, because it's brand new and they just want to make sure that it's tested out. So what they might do is stockpile, or if they know a company is going out of business, because sometimes it happens, the supplier may go out of business. So before that supplier closes down, they're going to tell the supplier, we need you to make an extra 3 months worth of material, so that gives us time to find a new supplier. We can source a new supplier. So they will get that bank build, what they call a bank build, in an expendable container, and then that will be stored in the warehouse, and they can pull that as they need it until it will basically cover them until they get the new supplier on board or change that part over. Okay, so corrugated board, basically the same. You know, we're looking at everything that you learn about corrugated, the concepts are the same, but as far as what's most common, you're looking at like a 250-pound burst or a 32 to 42 ECT type of corrugated box for single wall. And then you might go up to like a 350 for double wall. When you're looking at things like double wall or triple wall, those are going to be more like bulk bins, things that are getting shipped in large quantities, or they're very heavy. And that's when you'll see that. But, you know, everything you learn about corrugated is pretty much the same. It's just a matter of the sizes. Wood pallets, you know, I made a note here to add the Euro pallet, and so I'm going to add that. I added the ISPM 15. I highlighted that because I posted that today as supplemental information. So the ISPM 15 is something that you can refer to if you're working, not just in automotive, but anytime you're working with pallets. But the pallets, there are standards for automotive, and they're kept by the Automotive Industry Action Group. They have working groups, and they work on standards. So they will update standards from time to time for automotive. So there's a pallet standard. There actually are a couple. So I mentioned before, you have the 45 by 48 pallet. There's also one that's a 30 by 36, which is rarely used. And then there's a 30 by 32. So basically those are the sizes of the packs. So the 30 by 32 is a smaller pallet. You may see that, sometimes you may see that coming from overseas even, but it's a smaller pallet that is an automotive standard, but you won't see it as much as a 48 by 45. The ISPM, that is a standard for heat treating. And I don't know how familiar, you know, everyone's listening to this, how familiar you may be with ISPM. It came about in about 1996 or 97, the mid 90s, because there was a bug that was destroying wood, and it got shipped over by accident on a load, and then the bugs got loose and they started damaging trees. So in order to mitigate this damage to trees across the country, and not just in the United States, with other countries, they've figured out that if they heat treat these pallets coming from overseas, that it kills the bugs. So the bugs could not come into another country and proliferate. So a whole standard was put together. I think it's called the International Standard for Phytosanitary Manufacturing or something like that. But this, when you read it, it'll talk about heat treatment. You can either heat treatment or do a chemical treatment, and then you have to mark the pallet. And that's actually what this is right here. This is the stamp that shows it was heat treated. This is a European pallet, it says EPAL, EUR. That's a European pallet size, which is similar to the 48 by 45, but not exactly the same. It goes by the, metric standards. Okay, here's some other examples. This is a pallet box. So you'll see you've got basically a top, a sleeve and a cover, and then that is attached to the pallet. So that might be used for, heavy parts, metal parts, or large car parts, and it can be picked up by a fork truck and moved around. This is another example of a box that has feet on it that can be picked up by a pallet. So this is actually a fluted material here, and it can be picked up by a fork truck and moved around like a pallet. So I'm going to talk a little bit about pallets. I mentioned already about the heat treatment, and read through the ISPM. It's supplemental, again, not tied to the homework, but it's definitely something you want to print out and use if you start working in automotive. But really, if you're in any packaging industry that uses wood pallets, they follow that treatment to that process if they're shipping or receiving things from overseas. So it's something that's good to know and be aware of. So some problems with wood: you could have, cracking wood because of the moisture content. So you want to make sure that the pallets are seasoned. Sometimes you get companies that maybe are trying to save time or save money, and they may not go through the whole process of conditioning the wood to make sure that it's dry, and they want to get it out, or they just want to save money and skip a step. And that can cause you problems because you'll have breakage within your system for pallets, and that can cause many issues. Dangerous, they could be falling off, coming off of racks, higher racks up in the air. You could have wood debris throughout the plant. If you're working with parts that are sensitive to dirt and debris, that could become an issue, can also become a trip hazard. So there's a lot of reasons of cleanliness that you want to make sure that your pallets are not breaking up. Another thing is many of the parts for automotive are, they're really prone to rust. So, you might have something like a VCI bag that will absorb moisture and protect it from rusting. But if the pallets are soaking up more moisture, you might do all those things, but then the parts may still be prone to rust, because even if you use something like a VCI treatment to fight that rust, if the pallets are soaking up if the pallets are soaking up water, and those pallets are the parts are placed in the trailer, and it's a hot trailer, the moisture from that wood is going to make the inside of the trailer humid, and it could rust those parts. And this is where I talk about the treating the pallets, especially if they're going overseas or coming from overseas. I highlighted heat treated because initially the go-to process was chemically treating the wood, but they found that if they chemically treated the wood, that it would wear off, and then the bugs would, if there were any bugs, they would come back and they would start eating the wood. And that is something that, just so you know, customs looks for. That's one of the things that customs looks for. They will check pallets and look for the stamp that says it's heat treated, or they'll look for signs of a bug infestation. This ties in also that heat treatment, or that ISPM treatment, that also refers to wood crates too. So but one thing I need to let you know, most crates are made from plywood or chipboard, because the process to make plywood and chipboard uses heat. They're considered heat treated, and they resist insect infestation. So if you're looking at crates that have 2x4s, or they're using wood, untreated wood pieces, they also need to be meet the standards for ISPM 15. Wood crates are considered to be very sturdy and they can be customized. I have seen some wood crates that look like Santa's workshop just didn't know what they were doing, and they just like not take a couple pieces of wood and just nail them together, and before they even get it out the door on a pallet, it falls down. So you really, if you're working with crates, you want to use, crates. You see how these actually have been, they're standardized. You see they have fork entry, and they're all the same size. This has clips on it. These clips here, this is so that it put a lid on it, and the lid will protect the parts, but that lid can also be easily removed. And then all these clips that you see, this can be disassembled very quickly. So once those parts are taken out of or received, they can either be taken out, and that crate can be torn down pretty quickly and sent to recycling or wherever they might send it to. Or another thing is that they might, so the operator doesn't have to reach down into the pack. They might use this to disassemble these sidewalls, and then the operator can access the parts much more easily. This looks like this might be a car battery. So they would open that up, and then they can access any point of the part very quickly by taking out those sidewalls. Or use something like this that is made specifically for a certain part, and it might be something, this looks like this might be a wire harness, which is going to be the wires that are plugging in between like your radio and your air conditioner in the car, for example. And they go behind the dashboard, but you don't want them to get bent or crooked or tangled. So something like this might help separate them. So here this talks about the custom clips. Yep, those are batteries. And you can see what that looks like all assembled. I wanted to talk about returnable containers that are used in automotive. Generally, you're looking at things like trays, totes, bins, small bins or large bins, pallets, and racks, like steel racks generally. So the racks are steel frames, and if anyone lives in the Detroit area, you ever drive in the Detroit area, you will, if you're on one of the freeways, sometimes you'll see an overpass that's near an automotive manufacturer, and you'll see they have all these metal racks. Those are automotive packaging racks, and they're storing them outside, which they're prone to rust because they're metal. So, keep that in mind. If you're working in automotive and someone wants to store racks outside, that means that they're probably not using those racks anymore, and they're maybe planning to use them to piece together, use the parts for a new rack. But in general, they really shouldn't be stored outside and where they can be affected by the weather. Racks are big because they're usually used for big parts. They're usually able to be forked on a fork truck. Here you see the cost can be $1,500. That's very, very conservative. They might cost more than that. They can be very expensive, but they're generally used for very expensive parts. When I work for an engine plant, we ship the final racks, we ship the final engines on racks on a train to Mexico, or on a truck to Illinois from Michigan. So the racks were very robust, to the point where when we first started shipping these racks to Mexico, I had a test run set up on a train, and the train derailed during a mudslide, and the racks were still in good shape, and the engines were still working. So the racks can be very robust. And this, says because they're so big, more than half of the trucks that are bringing parts in, if you were to open those trucks, you would see more than half of those trucks contain racks, just because of the sheer size of the parts that the racks are holding. Okay, here's one example of a rack. I think this one is. This one says it's glass for a door, but it looks more to me like a fuel tank or something. But you can see here, they're separated. These look like they have separate cells so that these parts aren't touching each other. And then there is a rod that is keeping the parts from moving. But these rods, they lock up, but they're also easy to unlock so that the operator can reach the part pretty easily. And even though you see there are 4 different levels, they will have material handling equipment that will move those parts up and move that rack up and down so that they can just reach to the same level and grab the part. Okay, this is the glass door rack. So they're mixed up, but you can see there's basically like a seat belt and this holds it down so they don't move. And you can also see that it's forkable. Okay, yeah, that was a fluid tank rack. I knew that was one. So that was for washer fluid and it's plastic. So that's why they had it protected here, because you want to make sure that they don't scratch each other. There may be some, other parts that are metal on this that could scratch the one next to it. So this keeps them separated during shipment. And then for the glass, you can't really see it, but they have rubber stops in between. And sometimes like on this side, so you'll see this on the top, this arm has rubber stoppers on it. And this isn't the only one. There will be one in between each layer of glass. So like I said, you can't really see it, but there is a divider between each one. And there is a generally something like a rubber type of piece that will protect them. So it keeps them stable, and it also keeps them from hitting each other, and it keeps that from moving during shipment. Okay. Here are some other examples of racks. You can see you can make articulating arms that move. You can put them on tracks so they stay aligned. This one looks like it might be collapsible because you see on this arm here and over here, you have like a full piece of metal, but over here you don't see it. That usually means that it's collapsible or removable. And it's like that, so it can go up to the line, they can take this off, and then the operator can just reach right in and grab their part. Something like this that's so heavy, they're probably going to use material handling equipment like an arm or a suction that will pick the part up and drop it into the vehicle wherever they need it. This is a bumper rack. So you can see that the bumpers are not touching invisible areas. So that's something that's like when we talk about the A surface versus B surface versus C surface. And A surface is something that can be seen by, someone walking by the vehicle. And so if you're in a showroom, you don't want to have a scratch on a bumper. So this keeps it looking pristine from the minute that it leaves the showroom, leaves the manufacturing floor to get to the showroom. And then these are larger pieces of the body of the vehicle. And you will see that right here, you have 2 racks. They actually are stacking on top of each other, so you get more. So that would be similar to where I told you that this has nubs, and if they fit, it keeps it stable. So you could do the same thing with racks. And you can see here they have tracks and they have articulating arms so that they can take one part off at a time without the rest of the parts dropping out of the rack. So the operator can just pull what they need. This is an engine rack. This is a pretty big engine rack. But you can see it's stacked on top of each other. This one does not look like it's collapsible to me. But when I worked in an engine plant, we had racks that were collapsible because we were shipping them all the way back from Mexico on a train. So we wanted to get as many in on a train as possible and have fewer trips back and forth. Okay, you'll notice here, I'm gonna bring this up. It's not in the paper, but I'm gonna bring this up. When I think of something that's practical from a standpoint, if you're working in automotive, I'm gonna bring this up. In automotive, they avoid straps like the plague. This looks like a plastic strap, but this tells me that if they're strapping these two pallets together, these two racks together, there's probably some issue with how these racks are fitting together at the corner posts. So there must be unstable during shipment. And you don't want that. You want them to be stable. You want the racks to stack on top of each other. And you want the weight of this one to keep this one from moving. And you want the one on top to be stable enough from the stacking pins or the nubs that it's not going to fall off or jump off. Okay. Here are some examples of racks for the larger, the upper body. They actually have ways to hold the part in here so it doesn't move. So when you mention about tracks and nubs and posts and things like that, that's to keep them from moving in transit, not just the rack, but the parts too. Here's an example of, this would be called the dunnage. A lot of times they call this the dunnage or the carriage in a rack. So these usually, you can't really see it in this picture, but depending on what the part is, if it's like, say, a machine part, metal machine part, that's maybe could scrape something else, or maybe if it's a part that's, really sensitive to scratching, you can put material on these posts that are maybe rubberized or plastic that will protect the part. So if you won't have a hard metal surface rubbing up against the part or scraping the blue paint from that rack onto the part. Okay. Here is an example of packaging for wheels. Wheels are very difficult because they're round, and many times they could be, they have a lot of A surfaces because they're, very visible. The hubcaps or the rims, they may be, they do serve a function, but they're also very cosmetic. So this could be something that could deter a purchase from a from a customer if the supplier's wheels come in and they don't look good. So the tires aren't fragile, but from a standpoint of the amount of space that they take up, you could put them on a rack and they won't be touching or scratching each other. But sometimes I've seen them like this where they come in a box. This is a lot of extra material, a lot of extra handling, a lot of material to discard of after the fact. This is much more streamlined and clean. So try not to be biased towards returnable packaging, but sometimes it is, it's pretty obvious advantage. This would be a way some tires get stored on an interior rack inside the building, maybe in the supermarket, because maybe this might be an assembly area. So these might come in. And this is another advantage to using racks because they're positioned, they're already neatly presenting themselves. And if the assembly process here would be to take these wheels and put them inside the tires, then using the returnable rack packaging is much easier than using this, because now you've got to take, disassemble the packaging, and then you have to take that wheel out, orient it, and then put it up against into the tire, which may not seem like a big deal, but if you're doing it, if you're doing 1,000 vehicles a day, 1,500 vehicles a day, and you're doing 4 tires per vehicle, now, that's astronomical, the number that you're assembling together. Any questions so far? I know it's been an hour, so you have any questions, Brandon? Comments?
Yeah, I did have a quick question about the returnable rack that you had mentioned earlier, had the plastic straps on it. So I was really wondering, how would you go about fixing that issue? Is it just like a raising the punt inside of the racks, or what would you do?
So one of the first things that, we can talk about okay, someone else just entered. Okay, one of the things that you really want to do is to make sure you have packaging standards that are clearly spelled out. So you want to, in those standards, you'll say something like, no straps either at all, or no straps for specific parts. But then if you see these start coming in with straps, or you start hearing about the damage or something like that, then you would want to address that with the supplier. So it might mean that you have a new design for your rack. You may have to go through a design change. It's okay, someone is coming in, but they didn't come in. That's weird. Yeah, so that's what you want to do. You want to make sure, one, your standards are very clear. And if it happens, if you're seeing it, a lot of times something like that is a Band-Aid. So you want to look at, why is this here? This is not standard. It looks like a Band-Aid. That could be a clue that you need to redesign your packaging for whatever reason. So it could be that something changed with the part. It could just be that, it just got missed when it was designed, or it just may not have become apparent until you get into full scale production.
Okay. And then is that the same thing for the wooden crates? Because I know typically I see a lot of crates with the plastic around it. What are those straps called? They have the plastic ones and they have the metal ones as well.
Yeah, so a lot of times people, if they use plastic straps for crates, sometimes they will, but most of the time the metal straps are out. Like we don't use the metal straps because they can cut people.
Okay, makes sense.
Yeah, I thought I saw someone join, but they haven't come on, so I'm not quite sure why they didn't join. Okay, all right, so we'll go back. Okay, so we got wheels and tires. Plastic bolt bins, my favorite little toy here on my desk. They are available in standard sizes. The big ones are called bulk bins and the small ones are called totes. So usually if it's something that's either handheld or you have multiple totes on a pallet, you might have one that's 32 or 48 inches long, but it's still considered a tote because it doesn't take up the full footprint of a pallet. So for example, it matches a footprint of a pallet, right? Whereas something like this doesn't take up the footprint of a pallet. This would be considered, something like a tote or tray or something like that. Generally, when you start looking at plastic bins, they're made from high density polyethylene. And many times when they do the justifications, they may say 5 to 7 years, which is going to be what's considered to be the life of the vehicle for manufacturing, but they can last much longer than that. It's mentions here 10 years or more. I've seen totes that are significantly older than 10 years old. Okay, so this container is called a roll pack, and it's called a roll pack throughout the industry, no matter who makes it. So roll pack is a manufacturer, but I would say in this area, my experience has been working mostly with Orbis. So the totes are fairly interchangeable. They're very, very close in size. If you're working on a manufacturing floor, if you're picking up the bins and returning them, it's sometimes hard for them to tell the difference. To them, they're like, oh, they're big bins. They're 48 by 45 by 34, the standard bin size. They'll call it a roll pack, and they don't care who the supplier is. They will, send them back. And when I say the supplier, I'm talking about supplier of the packaging. And you can see here, this is what the bin looks like fully assembled. So this might be what you have when the parts are put into it, and it's going to get shipped like this, erected with this door. This is an access door. So these are handles. So you can open that access door with these handles. And then that access door can be opened on them either when they're loading those parts in and then closed, or if it's going to the line and the operator, they can take the top row pretty easily. And so they don't have to, they can't reach down very easily. So that instead of having to dig down into that, they can open that access door and access the parts that are at the second or the bottom level. And then this is that same pack that is collapsed. So you can see how much smaller this bin is once it gets collapsed. And when I mentioned that about the dunnage collapsing inside the bin, sometimes depending on the bin, there's enough space to store the dunnage inside of here when it's collapsed as well. Again, the common footprint is a 48 by 45 inch pallet footprint. It can be picked up by a fork truck, and there will be standard heights. So you've got 25 inches, which is usually the shortest one, 24, 25. And then the next height is going to be 34. And then the next height is going to be 50 inches tall. And the reason why you see those three heights is because if you're loading them in a trailer, generally it's like maybe 106 inches would be the height of the trailer inside when you load it. But so that you can manage the, say an inexperienced trucker loading into the truck, they have enough clearance. You generally look at about 100 inches and say 100 inches is a good general guide for how high you go, because if you go higher than that and you have an inexperienced fork truck driver, now the fork truck driver might be running the top bins or top boxes or top of any pallet at, up against the top of the door and damaging the items on top. But with that being said, those heights of the 25, 34, 50, that is equivalent to the 100 inches. So you can take a bin that's 48 inches by 40 inches by 25 inches high, and you can stack those 4 high. The one that is 34 inches high, you can stack 3 of those, and you're basically going to get just like a little bit over 100 inches, like 102 inches high. So you can stack those 3 inches high in a truck when you're loading the truck. And then the 50-inch one, you can stack those 2 high in a truck. So that's kind of where those numbers, that's where those numbers come from. And you could say, how many you want to ship in a trailer, but then they also, full, but then they also collapse down to different heights. So you can get more going back on it of the empties and reduce your freight cost. Sometimes you will see top caps that are used. So let's say you have products that are prone to dust. Now, this wouldn't necessarily work in a clean room environment where you have an electronic part that's really highly sensitive. But if you have something where you don't want it to get dusty, then something like a top cap is going to be good. Also, these top caps, you see these ridges here, they are made so that you can stack another pallet on top or another roll pack or bulk bin on top of it. Okay. So you can also get these containers and they can be modified to fit the special needs of your part. So here's an example of a roll pack. You see the access door open, but you see it's got dunnage inside of here. This dunnage looks like cloth dunnage. So that tells me that this part is probably prone to getting scratched and the parts need to be separated. Or maybe you have, sometimes you might have a part that is part plastic, but it has a metal clip on it. And that metal clip, if it touches the part next to it, it will scratch the part. So you want to protect metal clips from plastic parts, for example. So that's where you might see this. This is another example where they actually put rods across here and they hang these up, and it's almost like a closet hanger, right? And then they can put parts inside. This is basically a bag that's hanging from the hanger. And they can pull the parts out. And when they're done, they can push this to the side and go access the next row of parts. So when it's empty, it's kind of like when you're in a closet and you're pushing your clothes to one side, and it gives you room for something else. That's what this does. And then this is another modification where they have rigid cubbies that are holding parts. So this might be something, it may not be prone to scratching by itself, but you want the parts to be separated for whatever reason. Or it could be that maybe they're not sensitive, but maybe from a standpoint of manufacturing on the line and assembly, it's much easier to pull them out and orient them all in the same way by putting them in a bin like this. So sometimes, many times it is protection, but sometimes it is the ease of manufacturing that drives this type of dunnage or modification in this standard container. You've heard me say dunnage many, many times. So when you see something like this, it could be like a low density polyethylene. See this one, you can't really see it, but it's, okay, this one is made out of what many times people call it either like a plastic corrugated or Coruplast is one of the brands. It basically is a corrugated material, looks like corrugated board, but it's made out of plastic. So it can help prevent scratching. For the Class A surfaces that are prone to, that are visible to the customer, but you don't want it to scratch it. This mentions the spunbound or brushed nylon, and that's what I showed you before. These types of materials. You can kind of see some patterns on them, depending on what it is. But these are all used for dunnage. And these are, considered to be inserts that put them in. You see this one is a combination of corrugated plastic and foam. So that tells me that this part is prone to scratching, and you want to keep it stable and you want to keep it oriented in the same, they want all to have them all in the same position at the same time. And this mentions too, sometimes some parts are packed hot and you want to make sure that whatever dunnage you have is not going to melt. Okay, steel bins, you will see these for some heavy bulk items many times, like a large portion of an engine that's machined, for example. I've seen these used, these are probably about the only returnable packs that I've seen used overseas, and they get shipped from overseas and returned back. Because a lot of the overseas manufacturers, as you will learn in the video from Steve Beeler later, a lot of the overseas companies have been using returnable packaging for a long time, and pretty much everything virtually is returnable for them. And in some countries, they have shortages of wood grades that are appropriate for corrugated. So they may have a shortage of wood and paper for shipping boxes. So they've learned how to use and return metal bins. And because they're using it for longer trips and they're very heavy, and if they're going on sea containers or there might be moisture, these are going to be more robust. Let's see. So because these are used for, like I said, like things like machine parts and metal parts, a lot of those will have oil. So these bins can get very dirty. So you want to make sure that they're clean, that they're coming clean, because sometimes I've seen where people will use these to store things. And if they're dirty, then it can, get whatever they're trying to store dirty. Let's see. Okay, so this talks about like these bins being tugged to the line. When they talk about being tugged, this is the material handling equipment, the little trucks. It can be a fork truck, but they also have trucks that they attach the like this might go on a piece of equipment that has wheels on it, and then that's attached to another cart. So almost similar to a train. So, early on yesterday in chapter 1, when you saw the from the Ford plant where the Model Ts were coming down the ramp from the second floor, and then on the ground right next to it, they had some carts with wheels. That is very similar to what they use now to tug. So the tugger will hitch up to all these little carts and these flat carts, and they'll put the product, or they'll put returnable containers or boxes on those tuggable carts. And then those go, or they can be called dollies. Those will go to the line and they will deliver the parts. Then they can either put them on the rack, or they can like slide them, or they might go down a roller, but they are amazing that they can take parts out of those bins and very easily. So they might take them out, put them on a rack, or they might take that whole bin and put it in a spot on the line, and then they'll pull from that bin. When it's empty, it gets sent back. Okay, here are some specialized containers. You won't see these very often. These are usually used for things like liquid. So if you have a large, quantities, volumes of liquids that are used in the environment, like say maybe an oil or some kind of fluid or something like that, they might come in bulk from on a train or on a truck. They're usually used, they're not used generally by the automotive manufacturing plants, but some of the suppliers to the manufacturing plants may need some of these fluids to build what they're building. Okay, this is used for hazardous bulk fluids. You'll notice that CHEP manufactures these. We'll talk about CHEP later. And since these are usually handled by a third party, so you don't see these very often. Okay, so a ULD is called a unit load device, and these are usually used for shipping by air. So companies like FedEx and UPS use them. You can see that this is a regular plane, and instead of having seats like you would have a passenger plane, this has been configured so that it's got rollers and conveyors on it. And then these ULDs are shaped like the interior of the plane. And they can push these in, and this handle is used to pull it out. And these get pushed in, and as they put more of these in, this will move all the way to the back. So when this plane is full, this will get moved all the way to the back of the plane. And that's how UPS and FedEx ship their air. So if you're getting something that's an express shipment by air, it's going to be loaded into these bins. Okay. Totes, we talked about totes some. They are the smaller version of the bulk bins. In real life, they're going to be sizes like a 12-inch by 15-inch by 7-inch, 5-inch, 7-inch, 9-inch, something like that, 11-inch, 15-inch totes. These are referred to as Orbis totes. So even though the other ones are called Ropax and Orbis may make them, these are many times, they could be made by Orbis or Bradford. There are multiple different suppliers that make these. And I even had one instance where I had a supplier that made plastic injection molded parts for us, and they made their own injection molded totes, and they shipped the parts in those totes. So I would recommend that you, Google Orbis. I had a I had a catalog, but you can go online and you can see Orbis's ORBIS. You can see their catalog online, and you will see containers like this. These are collapsible, these are stackable. These have lids that open. You can stack more of these. So for every, you see, this is one row, but you could get 3 times back. So you've got, you could, for every 8 that you send, you might be able to send 24 back, for example. Some of these, they make them with like smooth inside bottoms so that you can clean them easily. So, you know, depending on where you are, like when I worked in the engine plant, a lot of the bins would come back with oil in the bottom. So, you know, we would have to come up with cleaning processes to make sure that the oil was gone, because even though they're supposed to go back to the same supplier, sometimes if it's the exact same generic tote like this, even though it's got markings on it to say return to supplier A or supplier pink or whatever, they will still send it to whoever they normally send it to. They don't necessarily break them out. They don't read what's on the sides. Mentions here that the weight limit of totes is 30 pounds, and that's because in automotive, that's pretty much the standard. They don't ship more than 30 pounds of material in a handheld tote. So you can see, you know, these are examples of handheld totes right here. There are other ones that are more common. We'll see those later, I think. So one thing when they talk about the gross weight, that's the total weight of what the person's lifting. So it's going to be the weight of the parts plus the tear weight of the package. So you want to, so if your tote weighs 5 pounds, you can only, and you're getting to that 25-pound weight limit, you can only put 30, you can only put 25 pounds of weight in that tote to get to that 30-pound limit, because you've got to count the weight of the tote as well. One good thing about these standard totes is that the weights are already established. So you'll know when you use certain totes how much they weigh, and you can subtract that out automatically from the weight and say, you know, so if you have a 6-pound part, for example, and you want to get to 30 pounds, you can subtract out the 5 pounds from your packaging, and you can say, okay, I need to make these parts get up to 30 pounds. And you are basically, now you're really looking at, you know, 25 pounds or whatever that might be. And then these are handled by fork trucks. So you're gonna have like a stack weight. When you start talking about stack heights, there's gonna be like a dynamic stack height and a static. So static's gonna be when they're just sitting like this in a warehouse, stacked in a warehouse like this. This is gonna be your static stack. But if you get these, pick them up with a fork truck and start moving them around, now you're looking at a dynamic weight, and that could change, because you want to make sure that whatever you're packaging, that your package can handle the weight when it's being moved around. So you can see here that you have these totes. These are examples of standard handheld totes that you see in automotive. You can see that this lid looks very similar to the lid that was used for that bin as a cover. And it's used because it uses the same footprint, and you could stack another pallet on top of it. This one is called a twin sheet because you can buy, the Orbis will sell this whole set. So this twin sheet, you get the top and the bottom, and then you get a number of totes that will fit into that footprint. So in this case, it's a 15 by 24 by 7. So if you're looking at a 15 on a pallet, on the 45-inch side, you're going to get 3 across right here, right? If you've got a 20 by 48-inch pallet, if you've got the 24-inch dimension, you can get 2 of those across the 48-inch side of the pallet. So that's where you get the 3 by 2. You get 6 per layer. And then if these are 7 inches tall, you have a top and bottom cap. You will know exactly what that height is. Generally, this is going to be about 5 inches. And then 7 times 4, 28. So, and then this might be another couple inches. This is probably about a 34-inch stack. So I think you could probably stack 3 of these in a trailer and like this with this type of unit. This is used as cloth straps. They're also called seat belts. So you can see here at the top of this actually has a clip. It is a seat belt clip. It's exactly like a seat belt you'd see, especially on an airplane. So underneath you have these cloth straps with the buckle on one end, and then you would clip it in here rather than using plastic or metal straps. Okay, so this talks about you want to keep them uniform. So you don't want to have a 24 by 15 by 7 tote here, and then something that is like a 24 by 15 by 5 here, because now you're going to be, 4 high here, but then you might end up being 5 high here. And you'll have a different number of parts in either one. Every once in a while, you might end up with a supplier that tries to send you 2 different part numbers on the same pallet. And that is something that you want to say no to. That should, if you write packaging standards for your product, if you're working in any company, but automotive specifically, you want to make sure that you clearly express that within your specifications or your standard operating documents, that every pallet is for one part number. You don't want to have multiple part numbers on a pallet because it just can become an inventory issue. People can mix up the parts. They maybe pull the parts from the one half of the pallet, and then that pallet that gets emptied, and then they'll take that pallet back to the warehouse, and then they put it in some odd place because they don't really know what it is, because maybe they thought it was part A and part B's are left, and they take it over to the supermarket or the warehouse and put it into the area for, the part B parts that are left. They thought it was a part A pallet. They send it back to part A. Those parts may not be ever found again because everyone's looking over in the warehouse for part A, not realizing they're sitting in the part B warehouse rack. Or maybe they put them back on a truck because they're like, we can't use this, and then no one can find it. And then as a packaging engineer, you're literally climbing around in trailers trying to find that half a pallet. And so those are some of the reasons why you don't ever want to have different size pallets or multiple parts, part numbers on one pallet. So according to the sequence parts will have mixed part numbers. I haven't really seen that used very often, but if they're sequenced, this would be the example of the radio, right? You can see like this, these are all different sizes in here, but let's say that these are radios and each customer 1 gets this one, customer 2 gets that one, customer 3, all the way through. There might be 20 customers worth of radios in here or sound systems. That might be the only time that it's, it might be admissible that you will see mixed parts in a tote. But because they're sequenced, they're going to be either barcoded or RFID tracked or something, so that people know exactly what's in that bin, and they're set in the order to match the orders on the line. So you've got to have a lot of technology set up for that. So if you're working at a supplier, they don't have much technology and they're very manual, you definitely want to avoid having multiple part numbers or multiple different totes on one pallet load. So according to this, the totes are not considered the best when you're shipping because the walls are thick. They're much thicker than you would have for a corrugated box. But they're stronger. So, and many times if you're looking at that just-in-time manufacturing, you don't need big totes anyway. You don't need to have a lot of material on the line. So you only want to bring what is needed to the line. So if this material, for example, were to last for like 6 hours, then my recommendation to the supplier would be this needs to come in 2 or 3 packs instead of one big bulk bin. They would need to figure out how to get a smaller pack for that and only bring what they need to the line when they need it. Here's some examples of vacuum form trays. You can have trays that are very thin, like this one, or this one that I got today in the mail. It's a vacuum form tray and it holds apart. Or you get something that's heavier like this. This is, I think this is, yeah, pistons. So this, I think that looks like a piston tray, but it's heavier, it's thicker, it's not as flexible, where this is holding lighter parts and you can see it's pretty flexible. If you're shipping something like this piston tray, besides the fact that the pistons are a little bit heavier, they're machined and the pistons are very sensitive to scratching. So if you ever have a car and your engine is knocking, that's a sign that like you have scratching in your cylinders or your pistons or something that's happening. And you don't want your parts to come in already scratched, because that's just going to exacerbate something. So this would be an example of a vacuum form tray that gets used on the line. So this might go right to the line side. It might be put on a rack or shelf so that the operator can easily reach it, or it could be an automated part. So sometimes you will see trays that are used for automation because it's more stable. The part can be picked right from that tray and it's sturdy enough to hold it. Okay, so plastic pallets, they're either thermoformed or molded. That twin sheet one that I mentioned earlier, that is thinner, but it usually comes as a set, and a lot of times too is called a twin sheet because they're basically mirror images of each other. Or you might actually have 2 of the same, the cover and the lid are interchangeable. That's another reason why they might call it a twin pack. Let's see. Okay, so this is what this looks like. If you were to cut this, you would see that it's hollow on the inside. And you got molded pallets that are high density polyethylene, and it's called structural foam. You'll see a lot of that with like the Orbis pallets, like this is a structural foam pallet. Rackable pallets are used a lot in automotive because sometimes the parts are heavy and they also need to go up in storage, because even though they may not keep many days of material, they have so many parts, so many SKUs, stock keeping units for the stock keeping units. They have so many of them that they have to have dedicated storage spaces for them, which would mean racks. So you want to make sure that your pallets are able to go on racks. For one thing, that they're strong enough so they don't break. Another thing is you want to make sure that the size is compatible with your rack, because if your size is not compatible with your rack, you could have, I've seen this happen before, where you see this rack, how you've got one pallet on this side, but then this rack is empty. If this pallet is too big, when the fork truck driver comes around and puts the pallet load or that unit load on the rack next to, that's adjacent to this, when they push it back to fit it on the rack because it's hanging off, because it's so big, it can actually push this unit load off onto the floor. And if there's someone standing there, or if you have material, it's going to crush anything that's under it. So it's really important that you want to make sure that your pallets are sturdy enough, strong enough to withstand being stacked and hold the product and not break while they're up in the air, and then also that they fit to the size of the racks that they're going to be put on. Okay, here's an example of the stackable pallet that I talked about earlier. That's basically what this is. So nestable pallets are good because you can stack more, so you can put product on them. But when they're empty and you want to store them, you can stack them similar to chairs, patio chairs, and you can spread them out when you need them, or you can stack them up, put them in a corner, and they take up less space. So according to this, they can be stacked 30 inches, 75 inches high in a standard trailer. So you can send a whole lot of these back. So you can, so for a 48, 45 pallet, you can get 26 of those footprints. So if you were to stack them, just put one on the floor, you can get 26. Generally, if you double stack them, if you have like a 50-inch bin and you double stack them, you now get 52, so 26 on one layer and then a second layer on top. So you could have the pallet where you could have, if it's double stacked, you could have 52 packed in a truck. When you go back to ship them back and you stack them 30 inches high or 75 inches high, you can have weeks worth of pallets to send back if you need to. You probably want to have a loop that's faster than that, because that means that you're shipping a lot more and making a lot more to ship out. But if necessary, you can do that. Okay. The export pallets that I mentioned, they're made for one-way shipments. They're usually thinner, and they're made to go, say, overseas or out of the country, and they don't expect them to get back. I mentioned the standard pallet. I think there's a picture of this earlier. It's made by Orbis, and it's called a Journey pallet. So you can look that up. And it meets that AIAG standard for sizing of either the 32 by 30 or the 48 by 45. The vast majority of what you're going to see will be the 48 by 45. And it's made out of structural foam. It's going to look like this. Is going to have a grating on it. And if you find that you're not using those standard AIAG sizes, then you have to get permission, or you need to make sure that it's okay, because it can cause issues with the racking, like I mentioned before, where maybe it's too big. There's a lot of issues you can have with that. But again, I will keep bringing up how important it is to have standard packaging and have your standards written out. So when you have your standards written out, you want to refer to like the AIAG, Automotive Industry Action Group standard sizes, and keep that together, because it really helps with things like inventory, tracking, knowing how many parts go on a pallet, uniformity, line side. That's part of this whole thing when it comes to standardization, because the line side products or line side equipment is generally static, and it's made to fit standard sizes on it. So once they come off the truck, that's where they come line side. Sometimes they might go in a warehouse, but some of them if there's a JIT plant, it can be taken straight to the line. Again, we mentioned that the handheld totes might hold 1 to 2 hours of material, but the bins could hold up to 4 hours. So if you have an 8-hour shift, that's half a shift. If you have parts where there's like heavy movers or they're really big, you might replace more than that. But another advantage to having standardized packaging and knowing exactly how many parts are coming into the containers all the time, you can plan what's called a route. So that those tugger drivers, the tugger drivers I talked about, where they have the carts and they tug the parts on these little carts and racks, they can plan a route just similar to like a bus route or train route, where they're like, okay, I'm gonna go over to station 1 every hour, and I'm gonna go over station 2 every hour, but station 4, I need to go there 3 times an hour. And they can plan that route out, and they can, deliver that way, or like an Amazon driver has they plan that route out ahead of time. But having standard packaging really helps to know how many parts they have coming, how many parts they're going to need, how often they need to replenish, and then the time at the time that they're returning, they know what that's going to be and they can schedule it. And then though the size of those racks and the equipment, they only have so much room, and they're limited to how much room they have. And that limit is going to be based on how often they need to deliver, how many hours of material they're going to have. And that's usually the limiting factor. It's planned out ahead of time that, 50 parts are going to fit in this footprint in a bin, and 50 parts last for an hour. That's how much room they get. They don't get room for 10 hours worth of material. They're going to get room for that hour or 2 hours or whatever amount of time they deem. So here it talks about the operator, so that when they take the part out of the container, and then when that packaging is empty, usually they're either, it's like, so if it's a full item or a pallet, once that pallet's empty, if it's a full bin or even a tote, the tugger driver, they can come by and see this is empty, and they will take it away. If it is a handheld tote, that tote, sometimes they will pull from the tote, and then when it's empty, there's usually a second row on the rack that they can just drop it in, it'll slide down and go back out to where the tuggers pick it up. So the tuggers can pick up anything that's empty underneath. So they kind of put it underneath on a chute. So this way the operator can just focus on pulling the parts out of the bin, putting it into the vehicle, or assembling it to whatever assembly process they have. And then they can just push that tote out of the way, and they don't have to worry about it. They don't have to go take it, move it, and get it out the way. It's not going to be in their way, and it keeps the area clean. Let's see. Okay. So when I talk about displaying, I think I mentioned before, some of these things are tilted. You probably see when I describe this, a lot of times I'm tilting this so you can see what's in it. These are some examples of tilt tables. Many times they are used for larger bins. I'm going to just kind of make up my own here. So this would be an example of a stand. Something like this would go on to right in front of the line, and then the operator, obviously much bigger than this, but the operator would stand right here and pull it, and they can maybe even adjust that height, that angle, and adjust it to their working needs, what their height might be. You see, there are many different types. Some are mechanical, some are stationary and they don't move, and some might be hydraulic, like this one. So this one uses air pressure, and it can tilt it as much as 80 degrees. Okay, these are the lifts. So this would be something where you put that pallet on a table, and then you can raise or lower it according to your need. So for example, if the operator is at this level and the operator just wants to reach straight in, and just grab at this same level all the time, instead of them bending over or standing up on their tiptoes, they could just raise that container up. So they're staying stationary and they're pulling, and they could just move that bin up or down to accommodate that, so that they're standing in the same spot all the time. And they're just reaching straight in front of them instead of up or down. And according to this list, the lifts can accommodate 2 tons of material. Okay. Turntables, similar concept, except instead of tilting or lifting, it turns so that, say if you have parts that are in this bin, the operator doesn't have to reach all the way across the bin to get the parts that are on this side. They would just turn it, so they don't have to walk around the bin. They don't have to reach in the bin. They would just use the turntable to turn the bin. So when they empty this side, they could just turn it, and now they can access the parts on that side. So double turntable, these are for like larger parts, or maybe you have multiple part numbers. So let's say I'm going to talk about my favorite yellow and black doors, right? So maybe you know that you're going to be running out of the order for black doors and switching over to yellow. But instead of, having a whole, have to bring a whole new thing out and getting rid of them, you can run through your black ones on this side, and then you turn the table, and now the yellow ones are facing the operator. Or if they switch in mid-shift, you can just turn that table around and you can access the parts. And then the people that are coming, the tugger drivers that are running these routes to deliver the parts to the line, they know that, okay, we know that they switched over to yellow doors, and we see some black doors sitting away from the operator. We can go take those back because we see they're not going to be used at all anymore today. We can take those back and put them back in the warehouse and bring more yellow doors and fill up this whole table with yellow. So, that's an example of one way that they're used. And then they can, they can have, when this side gets empty, or they could just turn it around and use this one, and the operator can just turn it instead of having to wait for someone to go get the material. So it also, this could be a route that instead of delivering twice an hour, now they're only delivering once an hour by having this turntable. Okay, so this is a fancy one. It tilts and it turns, and you can get 2 different pallets or loads on it. This is something that you might see, where, you have very large parts, and you can this is the only way maybe you can get an hour's worth of material in this area. The lift and rotate. This one is used when, the vehicle maybe, you're loading to the vehicle, but the parts may be down here. You don't want to dig down deep into the bin. You can open the access door and keep the parts at this level, at the same level where your reach is. You want the level to be where your hands are in reaching. So you can use this table to lift up and down. Here's a tilt and lift stand. So you can see there are a lot of different versions of it. This one doesn't rotate, but it lifts up and down, and then you can also tilt different angles. The operator would stand here and be able to pull out of that bin without having to bend or stand on their toes or twist or anything like that. Okay. Racks, the gravity flow racks. This is generally used for totes. So when I was mentioning about like space limitations, I mentioned, that this 48-45 footprint, that's more of something you're going to see for these larger bins, for some of these heavier duty material handling equipment pieces. But the flow racks, that's where I was saying where someone's pulling parts, and when that tote's empty, they can usually either put it, okay, this is an example. When this tote's empty, they would put the empty tote right here, and they would use gravity to go back to this side. So the operators on this side, the operator can reach for the part here, and it stays within their work area. They don't have to bend or twist. But when they're done, they would just drop it down here, and it would feed to the bottom of this rack. So this would indicate an empty container that needs to be sent back to their supplier. The tugger drivers, so the operator standing on this side of the rack, this is facing out to the aisle where the fork trucks and tugger drivers are. The tugger drivers come through here, pick up these empties, and keep going. So they don't have to stop at the operator and say, hey, operator, do you have any empty containers? That's their visual signal that there are empty containers. So when they come and deliver their hourly, so technically, let's say they have, this is an hour's worth of material, and it looks like it's probably 1-2 parts. This might be the same part. This is maybe an hour's worth of material. They've run through this tote, it's down here. If they're running, if the tugger driver is running in every hour here, they know that for every 2 bins they take, they should put 2 bins back up here. So it should be an even swap for them. And that should keep their flow going so that the operator doesn't have to stop and look for parts, but the tugger driver doesn't have to stop and ask, do you need more parts? That's their visual cue. Any questions, Brandon?
Nope.
Okay. Have you seen these before in the manufacturing? Are you seeing these in manufacturing and during your work?
Yeah, it's giving me flashbacks from my first week here. We did the plant visits, and these things were literally like everywhere. So especially along the assembly line and everything. So yeah, I've seen my fair share of these.
So yeah, there's a method to it. I mean, these are made specifically to fit these rails are made to fit certain size of totes. Even the height here would accommodate, you can adjust these, but you can adjust these to fit. They're modular, so you can have them fit certain standard sizes of bins and totes. Or I should say totes really, because the bins are bigger.
Gotcha.
Okay. These are some of the carts that I talked about that the tugger drivers use. So you can see the little hitch here. So this part might be hooked up to what the tugger driver's pulling, but then this is the hitch where they can actually attach multiple carts to the back and tug it like a train. You might see hand trucks for fork trucks, or you might see the big fork trucks. Some plants do not, they might run what they call a fork-free plant. So you may not see forks in the aisles, the fork trucks in the aisles. You may only see the fork trucks in the warehouse tugging or pulling or moving big pallet loads. But if you get onto the production line and they're delivering to racks and carts like this, they may not have any fork trucks in those areas. This would be an example where you have, this is what the tugger driver stands on and uses, and then these are the carts that are hitched up. Carts are pretty common. They, instead of having like a fork truck, heavy equipment, they're much lighter. They're not mechanical. They're just, the wheels are what's moving these carts and the tugger is pulling everything else. So you're not necessarily worrying about how heavy things are. They're not as dangerous from that standpoint. the aisle can be taken up with these tuggers. So if you're in a plant that uses tuggers, you know, I mentioned how the operator's on this side, but this side might be facing an aisle. There will be the tugger trucks up and down and this carts going down the aisle. So you can't see it in this picture, but these to me look like they might be either the tugger carts that are pushed on the line, or those might be, and then right behind that, you're probably going to have some racks. And then on the other side of it, you're going to have the operators that are assembling. So they do take up some room and they take up an aisle for delivery. They are quieter. You don't require like fork truck training. Years ago, I had to take like fork truck training, even though I didn't use a fork truck because I was in the plant and there was a chance that I would use a fork truck. I had to go through training and it was like a whole ordeal. And I had to get a basically like an internal truck driver, a fork truck license for that plant, just because I worked on the floor. So there are a lot more safety constraints. You don't have to have as much power equipment. However, it can take a lot of momentum to get them going, and they can be difficult to move around corners. So if you have any corners or anything, any turns, to get those tuggers to turn, sometimes I've seen those tuggers where once they start moving, if they turn the corner too sharp, they get stuck and they have to back up, and it can be very difficult. So if you're moving a lot of these, it may be better to have mechanical movement. You know, you may need like a powered tugger, you know, that has more power, similar to a fork truck versus maybe just like a hand truck or something. Okay, so dollies are, you know, basically carts. They're also called dollies, and they will put the totes or the bins on them and move them back and forth. So you might see this, these would have carts, totes and bins on them as they go through. And usually that's what you see moving through the plant, where they're picking up the empty ones to take back to the supplier, or they're bringing parts to the line for the operators to use. And a lot of times these bins, like they'll take these bins and they'll put them on some of that equipment that we looked at earlier. Let's see, here's some modifications for. So these are some examples of making carts that do it. So you lock the casters, you lock those wheels, and then you could, you know, institute that tilt on it. Or same thing with this one, you would lock the wheels. You always have to lock the wheels and then use this as a turntable. So then you don't have to move the bin off the cart onto the equipment. That's one of the advantages to that. Okay, so this is a rack that's placed on top of a dolly, and it's called a top hat. So you can see here, this is full of bins, and they just put the whole thing on the dolly and they just pull it that way, move it. So then this way they can just deliver this to the line. The operator would be here, and they would just, when they deliver it, they just leave it there. And when it's empty, they put all the empties here. When they see the empties are here, they would just take the whole thing, attach it back to the tugger, and take it back for the empties to be sent back. Here's some examples of other parts. This is a rack that has cloth or plastic dunnage in it. This is another dolly. It's kind of a hybrid light rack, a light duty rack. Looks like it has some sort of trim for headliners or doors on it. Okay. Let's see what time it is. Okay, I think we're almost done with this, but tomorrow I'm going to hit like the trailers and rail cars. This is more of the transport. So we're almost done with this section. I will cover this section, what's left, go over maybe some of the supplemental material and cover homework. So if you have any questions, if anyone needs to show up at office hours on Friday at 4 p.m. Eastern time, or set up separate office hours, let me know. But again, the homework is due Monday morning. So any questions, Brandon, before we close?
Nope, I'm all set.
Okay. All right, great. Thank you. And I will see everyone tomorrow. Bye-bye.
All right.